Hello class, welcome to this video on the Chapter 4 review. So we're going to start with lessons 4.1 and work our way all the way to 4.8, except for 4.4. So we'll do all the lessons except for 4.4. So starting with 4.1 and 4.2 questions. Determine if each of the following is a valid statistical question and explain your answer. All right, so how much money do high school students typically carry with them? How many quarters equal $10? So starting with A, so is this valid? And the answer is, well, to determine if something is a valid statistical question, we have to determine, does the value of each data vary? So if for part A, how much money do high school students typically carry with them? That value varies, and therefore it would be valid, right? Now, part B, how many quarters equal $10? That is a constant fixed value, and therefore cannot be a valid statistical question. So part A, we're going to say is valid because it's based on data that vary. All right, and then the second one is not valid because it can be answered with a single value that does not vary. All right, so now for the next question, identify the population and sample of the following settings. So a furniture maker buys hardwood in large batches. The supplier is supposed to dry the wood before shipping. Wood that isn't dry won't hold its size and shape. The furniture maker chooses 5 pieces of wood from each batch and tests their moisture content. If any piece exceeds 12% moisture content, the entire batch is sent back. So we want to identify the population and the sample. So in this case, the population is a set of all pieces of wood in a large batch, okay? So all pieces of wood in a large batch. And the sample are the 5 pieces, right, that were taken from that batch, right? So we have the 5 pieces tested. Okay, so you just have to be able to identify the population and the sample. Really straightforward. All right, so the next question is identify whether each scenario describes an observational study or an experiment. So remember, an observational study simply observes. They do not impose treatment, right? Whereas an experiment imposes treatment on the experimental units. So it says here, can using indulgent names make college students more likely to eat their veggies? Each day, a cafeteria at Stanford University randomly labeled a vegetable dish in one of 4 ways. Basic, beets. Healthy, restrictive, lighter choice beets with no added sugar. Healthy, positive, high antioxidant beets, and indulgent, tangy, lime seasoned beets. The number of students choosing the veggie was highest when the indulgent label, followed by basic, healthy positive, and healthy restrictive. All right, so is it an observational study or is it an experiment? Well, in the first case, we have an experiment, right? So this would be an example of an experiment because treatments were imposed. Okay, so each day there was a randomly assigned label for a veggie dish. And then it was the 4 labels, right? So we got basic, healthy, positive, so on and so forth, right? Highly restrictive, and indulgent. Okay, so we do have treatments in various groups here that could impact the result. All right, so part B, a University of Helsinki study wanted to determine if chocolate consumption during pregnancy had an effect on infant temperature at age 6 months. Researchers began by asking 305 healthy pregnant women to report their chocolate consumption. 6 months after birth, the researchers asked mothers to rate their infant's temperament, including smiling, laughter, and fear. The babies born to women who had eaten chocolate daily during pregnancy were found to be more active and positively reactive, a measure that the investigator said encompasses traits like smiling and laughter. So this is an observational study because no treatments were imposed. They were simply asked to report their chocolate consumption. They weren't necessarily asked to eat a certain amount of chocolate or anything like that. So this is an observational study. So we can say women were not told to eat certain levels of chocolate, but rather to merely report their chocolate consumption. Okay, so now the next one, how does social media use affect the mood and well-being of college students? So we had 143 students at UPenn helped answer this question. At the beginning of the study, they all took a survey to measure their mood and well-being. Then half were chosen at random to continue the normal social media practices. The other half were limited to 10 minutes per day for each of Facebook, Snapchat, and Instagram. Social media use was verified by screenshots of battery use. The group that had limited social media use had significant decreases in loneliness and depression compared to the other group. So this is an experiment. We have treatments being imposed. Since treatments were imposed, students were assigned at random to various uses of social media, or I guess various levels of social media use. In different platforms. Okay. All right. So the next question, it says, you have probably seen the mall interviewer, clipboard in hand, approaching people passing by. To estimate the mean amount of money that city residents plan to spend on holiday gifts, the interviewer surveys 100 mall shoppers. Explain why the sampling method is biased. Is the mean amount reported by the people in the sample likely greater than or less than the mean amount that all city residents plan to spend? Okay, so this is the sampling method. So the sampling method. So the interviewer is using convenience, right? Is using convenience sampling. Because people at the mall are more likely to be chosen than other city residents. So because the people at the mall tend, and we can say tends, like tend to say they might be tending to spend money, right? So we can put that. So because people at the mall tend to spend more money, the mean amount reported in the sample is likely to be greater than the true mean amount for all city residents, because you're going to be getting they're going to be surveying the mall shoppers, and so their estimate is going to be greater than what it normally would be. All right, so next one, it says the newspaper readers sometimes write letters to the editor, hoping that their opinions will be published in the paper. The editorial staff at a local newspaper keeps track of the content of each letter that is submitted. After a controversial decision made by the mayor, 90% of the letters to the editor express opposition to the mayor's action. Explain why this sampling method is biased. Is 90% likely greater than or less than the percentage of all city residents who opposed the mayor's action? All right, so this right here is a voluntary response sample. So they used voluntary response sampling, which explains the bias, right? So in this case, it's likely that let me just say the readers, right? That the readers who chose to write letters are strongly opinionated, which would bias the results. So that means 90% of the letters is likely, or yeah, 90% of the letters opposing the mayor is likely greater than the true percentage of all city residents opposed to the mayor. Okay, so now the next one is identify the sampling technique for each scenario. Okay, so which sampling technique is being used? So, all right, so we got a mineral water company wants to find out why people choose a particular brand of mineral water. So the first thing, a mail-in response card is attached to the neck of every bottle of mineral water the company sells. Okay, so they put a card there, it's a mail-in card. Well, if it's a mail-in card, then they choose to mail that response card in. And so that's a voluntary response, okay? All right, it says to phone every 200th person who mails in a coupon as part of a money-back offer. So they're going to phone every 200th person. That's systematic, okay? Systematic sampling. Phone 400 numbers chosen randomly from all the residential phone numbers in a province. So that's simple random sampling. Okay, so SRS. So mail questionnaires to 200 men and 200 women chosen randomly from a list of men and a list of women compiled from a market research company's mailing list. Okay, so that's going to be stratified. It's because you have two groups of people, right, that are homogeneous in each group, and you're choosing a certain amount of each group. Okay, so that's stratified. Stratified random. All right. And then we got asked the first 20 people seen carrying mineral water in a park on a summer day. So you're asking the first 20 people that just are in a park. So that's convenience, okay? So that's kind of like the mall example, convenience sampling. All right, so now we're at 4.3. So identify the non-random sampling technique used here. All right, so a researcher is studying a rare disease. He speaks to his current patients to ask them to refer others they know with the same condition. So this is known as snowball sampling. You're asking your current here in this case people that you know and that are in your study, and you're asking them to refer you to others, right? So that's called snowball sampling. All right. You want to take a survey to get an estimate of the average of the number of friends people have on Facebook. You post a link for everybody using the social media platform to take the survey. So that's a link. So that's a general invitation. So that's voluntary response sampling. Part C, you want to know how much people on average spend on groceries in your county. You decide to survey residents in your neighborhood. So because you're serving them in your neighborhood, that's convenience, right? When you're really trying to do it in your county, but you're serving them in your neighborhood. So that's convenience sampling. A company wants to test a new smartphone app. They divide the population into age groups and gender. They select a certain number for each subgroup based on availability to ensure the sample reflects the target market. So that's quota sampling. There is a vacant position at a particular company. The company committee wants to select someone for the position from the pool of applicants. They seek applicants who meet all of the qualifications. So they're specifically targeting people, right? People with qualifications. So that's purposive sampling, right? So they're selecting certain people. All right, so here's the next question. The director of student life at a university wants to know what percent of students eat regularly on campus. To find out, the director selects a random sample of 300 students who live in the dorms. Explain how undercoverage might lead to bias in this study. Is the percent from the sample likely greater than or less than the percent of all students? All right, so this is talking about undercoverage bias. Remember, there's non-response bias, there's undercoverage bias, there's things like that, and then there's response bias. So here we're talking about undercoverage bias. Okay, so in this case, we could be leaving out the students who don't live in the dorms, right? Because not all college students live in dorms, right? There are students who live in the area that may still live with their parents, or maybe they have they own a home or apartment or something like that, and they do not live in the campus, and so we're leaving those students out, and that's called undercoverage. All right, so it's undercoverage bias because the students who don't live in dorms are left out of the sample. So is the percentage of the sample going to be likely greater than or less than the percent of all students? Well, some of these students will live off campus, and therefore they're less likely to eat on campus, right? So some of these students, so I'm just gonna say these students, or a lot of these students may not live on campus and are less likely to eat on campus as a result. Therefore, we would expect that whatever we get from our sample is going to be greater than the actuality, because we're leaving out those students that normally wouldn't be spending that much money. Okay, so therefore, the percent from our sample is likely greater than the true percentage for all students. All right, suppose an SAT preparation course makes the following statement in their advertising brochure. We asked our graduates to report on their SAT scores before and after taking the course. The mean increase in SAT scores for the 500 graduates who responded was 210 points. 210 points. Explain how non-response might lead to bias in the study. Is the mean of 210 points likely greater than or less than the actual mean? Okay, so then there might be people that took the course, but they didn't improve. And if they didn't improve, they might not respond, right? Because there might be a level of embarrassment there. So we want to take that into account. So there may be people who took the course and did not improve. So I'm going to say this level of embarrassment may discourage them from responding. So we have some non-response bias there, and then on the other side, you might have people that did improve their scores, right, and are happy to share. Right? And so if they're happy to share their success story, then you're likely to get those people. And so the value that the 210 points is likely greater than the actual mean increase, right? There may be people who did very well and are likely to share their success. Which may lead to an overestimate of the true mean increase for all graduates. Or for all participants in the course. I'm going to say for all participants of the course. All right, so now let's look at the next question. Identify the flaw in each survey question. So what are the flaws here? It says, which type of artificial sweetener do you think is the least unhealthy? All right, so there are a couple of things in this question. First off, you might have, it might be a biased question because sweeteners do not necessarily. So it might be biased because they would say, okay, which type of artificial sweetener do you think is the least unhealthy? Which means that they're implying that artificial sweeteners are unhealthy, right, in general. So this might be a biased question, right? So we're going to put this as a biased question in the way it's worded. But it's also it can also be confusing because they need to specify, right? Needs to specify what is considered unhealthy, right? So unhealthy relative to what? Is it unhealthy relative to sugar? Is it unhealthy relative to something else, right? What did they mean by that? All right, so do you approve of the mayor's political agenda? Okay, so this is a very broad question. Okay, so question is too broad. What in particular are you what in particular are you asking that is approved, right? There's tons of policies and things like that. All right, and then part C, how long have you studied for this examination? So it's a confusing question as well, right? So when you say how long have you studied for this examination, you really should say it. How many hours did you study for this exam, right? So confusing with wording. All right, and then part D, how long have you, or we just did that one. If a plane were to crash on the border of New York and New Jersey, where should the survivors be buried? So again, confusing as well. So it's confusing because if you look at where should the survivors be buried, right? That should say where should the victims be buried. So confusing wording. Okay. So there's, different things that you can take into account. So there's other types of survey questions. So for example, there's double-barreled, which you have multiple things going on. Then you have double negatives and things like that. So you just want to make sure whatever type of survey question you have, make sure to identify the flaw. Whether it's biased, whether it's confusing wording, whether it needs to be more specific or anything like that. All right, so lesson 4.5 and 4.6. Is fish good for the gut? Researchers tracked 22,000 male physicians for 22 years. Those who reported eating seafood of any kind at least 5 times per week had a 40% lower risk of colon cancer than those who said they ate seafood less than once a week. Based on this study, is it reasonable to conclude that eating seafood causes a reduction in the risk of colon cancer? All right, so or causes, okay? We can't assume that it causes, okay? So this answer is no. It's possible that those who ate more seafood maybe exercised, right? And maybe they had healthier habits, and so we won't be able to eliminate the effect of exercise unless we do an experiment, right? So it's a confounding variable. It's possible that those who ate seafood more, who ate more seafood, I guess, or who ate seafood more frequently. Let me just do that. Also exercised more. Which would also decrease the risk of colon cancer. All right, so then in that case, it would be hard to untangle that relationship, right? So if both of these are true, we would see a relationship between those two, even if seafood has no effect, right? Okay, so if true, there would be a relationship between eating seafood and colon cancer risk. Even if seafood has no effect on the risk of colon cancer. All right. So that's just another way, wording that. You can word it in a similar fashion. Okay. So the thing about these responses is that they're open responses, and so you just want to make sure you explain, you carefully explain what you mean. All right. So the next question: the 5-second rule states that a piece of food is safe to eat if it has been on the floor less than 5 seconds. The rule is based on the belief that bacteria need time to transfer from the floor to the food. But does it work? Researchers from Rutgers University put the 5-second rule to the test. They used 4 different types of food: watermelon, bread with butter, and gummy candy. They dropped the food onto 4 different surfaces: stainless steel, ceramic tile, wood, and carpet. And they waited for 4 different lengths of time: less than 1 second, 5 seconds, 30 seconds, and 300 seconds. Finally, they used bacteria prepared 2 different ways in a tryptic soy broth or peptone buffer. Once the bacteria were ready, the researchers spread them out on the different surfaces and started dropping food. List the explanatory variables and the number of possible values for each variable. All right, so let's go ahead and list out the variables. So for part A, we have the type of food, right? So there was different types of food, gummy, candy, and all that, and there were 4 of them. We also had the type of surface. Let me just list them all out here. We had type of surface, and there are 4 types of surfaces. And then we had length of time. There are 4 of them. Like one of them was 300 seconds, things like that. Or yeah, I think it's 300 seconds. Yeah. And then we had the bacteria preparation. So we got we'll say the prep method. I guess you can say the prep method. And there was the 2 ways: the tryptic soy broth and then the peptone buffer. All right, so there you go. So that's the number of possible values for each. And then if the researcher used every possible combination, how many treatments were there? Well, it's 4 times 4 times 4 times 2. All right, so it's 8. So that's a total of 128 treatments. Let's say 128 possible treatments, but I'm just going to put treatments. All right, and then we're going to list 2 of the treatments. So you just got to, let's make up 2. So we could have one on stainless steel, watermelon, one for 1 second. Okay, and then, yeah, so stainless steel. So watermelon. Dropped for 5 seconds. On stainless steel. With bacteria prepped in peptone buffer. Okay. You can also do the gummy candy. Let's do the gummy candy because I think that was one of them, right? Yeah, gummy candy. On wood for 30 seconds, right? So we can say gummy candy drop for 30 seconds on wood with bacteria prepped in tryptic soy broth. Okay, so there's just 2 of the 128 possible treatments. All right, so the next question says the changing climate might affect the amount of rain that falls during different seasons. 18 plots of open grassland, each with an area of 70 square meters, were available for a study. One response variable is total plant biomass produced in a plot over a year. Kenwin Suttle and his co-workers at the University of California at Berkeley wanted to compare the effects of 3 treatments: adding water equal to 20% of annual rainfall during January to March, adding water equal to 20% of annual rainfall from April to June, and not adding water. Explain why it was necessary to include a control group that didn't get additional water. So just explaining about the control group. Okay, so why do we need a control group? Control groups allow for baseline comparison. So we want to it serves as a baseline to make comparisons, right? So so the control group in this case shows how much the plants let's see, is it biomass? Yeah, how much the plant biomass how much plant biomass would be produced without adding water, which serves as a baseline. to determine how much additional additional mass is produced in different seasons. Okay, so it's likely that the plants would have grown anyways without water. And so we want to see, okay, well, if it grew anyways without even adding water, then how much would it grow extra if we did add water in different amounts, right? Or for different, to produce in different seasons. Okay, so we would just want to be able to compare that so we understand. All right, so the cost of a meal might affect how customers evaluate and appreciate food. To investigate, researchers work with an Italian all-you-can-eat buffet to perform an experiment. You have 139 customers were randomly assigned to pay either $4 or $8 for the buffet, asked to rate the quality of the pizza on a 9-point scale. Customers who paid $8 rated the pizza 11% higher than those who paid only $4.60. Describe how the researchers could have randomly assigned customers to treatments using identical slips of paper and a random number generator. Okay, so we have 139 customers. So if we were to do the slips of paper, we would need 139. Okay, so let's see. So we're going to say use 139 slips of paper, writing A on 70 slips and B on the remaining 69 slips of paper. Then you want to shuffle/mix the slips, selecting one for each customer. Those receiving the A slip will pay $4 for a buffet. Oh, this should say $4, not $4.60, by the way. That's a typo there. It's $4 or $8. And those and those with B slip will pay $8 for the buffet. Okay. All right. So that's part A, and then now part B, and we're going to use a random number generator. Okay. So label each customer with a unique number or integer from 1 to 70. Now let's do 1 to 1 because there's 139, right? Yeah. So from 100 to 139. Then I'm going to say randomly generate 70 different integers between 1 and 139. Those with these chosen labels will pay $4 for a buffet. The rest will pay $8. Okay. All right. So that's how you can just describe how you would use these two methods. All right. So the cost of a meal might affect how customers evaluate. Oh, I think we did this one already. Oh, yeah. So this is the one that we just talked about here. But instead of talking about the how to describe the method, this time we're going to say explain the purpose of random assignment. So we talked about how we can randomly assign them, but now what's the purpose of random assignment? We want to avoid confounding by creating two groups that are roughly equivalent. Okay. So the purpose of random assignment is to avoid confounding by creating two roughly equivalent groups. Okay. And that's really what you need to understand. All right, so are politicians more available to people who donate money to their campaigns? Researchers had members of a political organization attempt to schedule an appointment with members of Congress to discuss the banning of a particular chemical. Callers were identified as either a local campaign donor or local constituent, with the identification determined at random for each member of Congress contacted. Otherwise, the protocol for the calls was identical, including the details of the meeting requests, which were delivered by email. Results. Donors were more successfully obtaining meetings and were given better access to a higher level of staff, including the member of Congress. Identify one variable that the researchers kept the same. Well, they said that the protocol for the calls was identical, right? So, so part A, the details of the phone call to members of Congress were identical otherwise. Okay, now explain how keeping this variable kept the same helps prevent confounding. So if one group had different details discussed, it would be hard to tell if the details or the caller's designation, the caller's label, I guess you can say, or designation, was the cause for the difference in success rate. In obtaining meetings. Okay, so this is how you can prevent the confounding by keeping the variables constant. That way you can see, okay, it can't be the details because they were all the same. It has to be this, right? The one thing that changed. Okay, so now let's look at 4.7, 4.8. One of the most popular web-based long-distance videos and phone service is Skype. How will the appearance of ads during calls affect the use of this service? Researchers designed an experiment to find out. They recruit 300 people who have not used Skype before to participate. Some people get a version of Skype with no ads. Others see ads whenever they make calls. The researchers are interested in frequency and length of calls. Outline a completely randomized design for this experiment. Okay, so how many people? We have 300 people that volunteered, right? They recruited them, which means when they say recruit, that means that they volunteered for the study. All right, so we got 300 volunteers. Now it says some people. Okay, so it says the researchers are interested in frequency. Okay, so it says some people get a version of Skype with no ads. Okay, so it looks like some people get a version with no ads, and then others see ads when they make calls. Okay, so then we can say it says a completely randomized design, which means that they did randomly assign them. So that means they randomly assign them to either with no ads or with ads. So we're going to say, okay, random assignment. We have our groups that they told us. So random assignment, we have group 1, which is 150 volunteers. We had group 2 with another, it says half, right? Because it says, well, we have 300 people, so ideally you would want half in each anyways. So let's do that. And then this one is with ads, without ads, and then you want to compare. Compare frequency and length of phone calls. Okay, so there's your basic outline of the experiment. Okay. All right, so it's an experiment randomly assigned over 350 subjects to echinacea, a popular herbal supplement, or a placebo to see if taking echinacea reduced the length of a cold. Results: the colds lasted longer on average for subjects who received the placebo than for subjects who received echinacea. But the difference wasn't statistically significant. Explain what it means that the difference was not statistically significant. Okay, so if it's not statistically significant, that means that the difference was too small enough that it could be explained by chance. Okay, so that's what it means. So the difference in mean lengths of the cold, I guess, in the two groups was small enough that it could be explained, or it's likely to be explained by chance variation in the random assignment. Okay, all right, so let's look at the next question. So are people influenced by what others say? Michael conducted an experiment in front of a popular gym. As people entered, he asked them how many days they typically work out per week. As he asked a question, he showed the subjects one of two clipboards, determined at random. Clipboard A had the question and several responses written down, where the majority responses were 6 or 7 days per week. Clipboard B was the same, except most of the responses were 1 or 2 days per week. The mean response for the clipboard A group was 4.68 days, and the mean response for the clipboard B group was 4.21 days. Calculate the difference in the mean number of days for the two groups. All right, so we're just simply subtracting the two, right? So we got 4.68 minus 4.21 equals 0.47 days, and that's it. Now, 100 trials of a simulation were performed to see what differences in means would occur only to chance variation in the random assignment, assuming that the responses on the clipboard don't matter. So we're assuming that the responses on the clipboard doesn't matter, just by chance we would see certain differences, and we're simulating that 100 times. Okay, so the dot plot shows the results of the simulation. All right, so there is one dot at a difference of 0.8. Explain what this dot represents. So they're talking about that one right there. Okay, so this dot just represents one possible random assignment. Okay, so one possible random assignment that resulted in a difference in means of 0.8 days. All right, so based on the results of this simulation, is the difference from part A statistically significant? Explain your reasoning. Okay, so we need to see, at 0.8. Actually, we're going to look at it says based on the results of the simulation is the difference for part A. So let's look at the 0.47. Is that statistically significant? Well, if you look at here, 0.47, this is 0.6, this is 0.4. And so this is probably over here is, we can see 0.5 is here, right? So 0.47, this probably could be about 0.47, right? So So we can say, okay, so that's about 0.47 or greater, right? That's really close to 0.5, so that's actually more like 0.48 or 0.49. So we could do that. So we want 0.47 or greater. Anything, 0.47 or beyond, basically. All right, so that looks like there's 16 dots there if you count them. And there were 100 trials. So really, we have 16 out of 100, which is 16%. Okay, so the difference, so because this is less than, or this is greater than 5%, that means that it's not statistically significant. If it's less than 5%, then it is significantly significant. Okay, so that the reason why it's not is because 16% is likely to happen, right? So 16% is a decent chance. So it is somewhat, so I'm going to say it's somewhat likely. To get a difference this big or greater simply due to chance variation in the random assignment. Okay, so it's somewhat likely to get a difference this big or greater simply due to chance because it's 16%, which is a decent probability. All right, so a long-term study and analyzed data from 3,462 randomly selected adults in Lausanne, Switzerland. And the sample, 10.7%, reported that they typically take 6 or 7 naps per week. Can we generalize this result to all adults in Switzerland? All right, so did they randomly select the adults? And they said yes, they had random selection. If they have random selection, that means they can generalize it to all adults in that area, or in this case, in Switzerland. And it's in that one city. Okay, so not all of Switzerland, but in that one city. Okay. Let's see. So I guess we could say no, we can't do it to all adults in Switzerland, but we can do it to all adults in the city. So I guess we should be more specific, right? So the answer to A is no, because we can't do it to all adults in Switzerland. No, so I'm going to put no. The sample was taken from those in Lausanne, city of Switzerland, and not anywhere else. Okay, so cannot generalize results to all of Switzerland. All right, what is the largest population? Well, we can only do it to all adults in that city, right? All adults in. Okay. All right. So let's look at the next one. So now this is the same kind of thing, but now it says, in addition to questions about napping, researchers asked questions about cardiovascular disease. A greater proportion of adults who reported taking 6 or 7 naps weekly had cardiovascular events, heart attacks, than did adults who reported taking fewer naps, and the difference was statistically significant. Based on the study, is it reasonable to say that napping frequently causes cardiovascular problems? And explain your answer. All right. So So in this case, we cannot say cause and effect unless we have random assignment. So they didn't randomly assign them to do, for example, different number of naps or one group with no naps to see if that affected cardiovascular issues, right? We didn't see anything like that. And so therefore we cannot say cause and effect, right? So we're going to say no, since researchers did not use random assignment. To different or to groups with different levels of napping. Okay, and so there's no random assignment to groups with different levels of napping, so we wouldn't be able to say that it would cause it because we don't really know, you know, based off of, because there's no treatment groups or anything like that, so we can't see if it actually caused it by varying the different levels. All right, that's going to do it for the video, guys. Hope you found this useful and informative, and as usual, I'll see you in the next one. Let's wrap it up.